So let's go through the event loop first, and then we'll jump back to here, and we'll cover node stuff. So the event loop this is kind of JavaScript's runtime, and this is the whole thing. We're going to focus on just the JavaScript runtime, and then we're going to go back to this full thing. But briefly, JavaScript executes things based on a simple stack. So the JavaScript runtime itself is heap what's in memory, and then a stack what's currently executing. And the stack fills up with functions, and they execute, and they go off the stack, and that's it. It's really simple. It's single-threaded. The event loop is how JavaScript kind of cheats its single-threaded nature by offloading tasks to system processes, third-party APIs, that kind of thing, to any external API, basically, to do processing, and then it just calls a callback whenever it's done. So me saying JavaScript, being single-threaded, it sounds like it might be slow or it might be a problem, but it's really not a problem in JavaScript if you keep everything async, if you kind of offload everything and don't do any heavy lifting in your JavaScript code itself. So it's very similar to, say, doing something very CPU intensive in PHP. Probably not a good idea. You're probably going to offload that to ImageMagick or something if you're doing image resizing, or FFmpeg or something if you're doing something with videos. It's very similar model. You just offload it to something else, then it stays fast. So JavaScript has exactly one call stack, single-threaded. It's only currently executing code, and these examples are live examples. I'm going to step you through exactly how JavaScript's going to execute, and then we'll see what it does. So this function, first of all, I'm going to put an anonymous function at the bottom around everything, because I'm assuming that's getting wrapped. That's basically just saying this is executing in its own scope. So a lot of times that's called like an iffy in JavaScript, like you wrap everything in a self-invocating expression. But the first thing we're going to do is call print username. At the bottom there, we've called a function, so it's going to call that function. It's going to call that function, calls combine names. We're going to call combine names so combine names goes on the stack. Combine names calls concat, so concat's going to go on the stack. And then concat returns something, so it's going to get popped off the stack. And then that returns the result of concat, so that's going to get popped off the stack. Print username calls console log, that's going to go back on the stack. And then that logs the console, gets off. And then print username is done, and it gets off. And now we're done executing. And that's how JavaScript works. So really, really simple conceptually, just with the call stack. And it gets a little more interesting as we go along. Some things you need to know, though, is that the call stack does have a limit. I know a lot of you, if you call a recursive function, a lot of you have seen something like this, maximum call stack exceeded. This is just to say that the call stack has a finite limit to how many functions you can put on the call stack. And if you put too many, your program's just not going to run. It's going to stop. And that upper limit is fairly high, but it's different for each environment. So, it's like several tens of thousands. So you probably shouldn't hit it unless you're doing something like recursive and things like that. So that was just the heap and the call stack there. Now we're going to look at the whole JavaScript ecosystem and where it's going to be running. So the callback queue at the bottom, it basically holds a list of callbacks that are going to be called. And this, unlike the stack, is unbounded. So you can put as many callbacks as you want, and they will just run whenever the stack is empty, but when it's their turn to run, essentially. And you can add things to this queue manually through a set timeout or a set immediate. So if you've ever solved a problem with JavaScript the order of execution on functions, where you're trying to get something to happen after something else happens and it doesn't, and then you add a set timeout and it works, this is why. You're basically putting it on the event queue instead of the stack. And that's important because I'll show you exactly how those work together here in a little bit. So and the external APIs are essentially how things get added to the stack. So set timeout and set immediate. And next tick are like external APIs that then add something to the event queue. So other examples are any network like Ajax you do, any DOM manipulation, any, well, DOM manipulation is synchronous, but it's actually a browser API. It's not like a JavaScript thing. So if you run in Node, you obviously don't have a DOM. So any, timeouts, intervals, file system, database, all that kind of stuff is all external APIs. So actually probably most of what you use in something like Node or JavaScript is probably actually using an external API, because the JavaScript runtime itself is fairly small. So it's just a loop. They call it an event loop. It's a loop that is continuously running, and as soon as it gets something on it, it says, hey, go do this thing, go, hey, database, go get me these records, and then it attaches a callback, and then it keeps running. It doesn't stop after that. So that's what makes JavaScript so fast. It only this is the key thing. So I should have bolded the second bullet point here, but it only dispatches when the call stack is empty. That's very, very important. This is how this is core to how JavaScript works, and it's the reason why some JavaScript code is blocking. So I'll show you an example of async. We're using a simple set timeout. We call that set timeout function first, and then we call that set timeout as an external API. So it says go do something. JavaScript itself is not keeping track of how much time has elapsed. Like that's some other process. And then then that console log runs, that next function, that next line there, it logs whatever. And now the call stack is empty. Our program's executed, but we have that external API set timeout. Timeout's done, and then it puts it in the callback queue. Since the call stack is empty, now that goes in the call stack to be executed. So then we execute our do timeout function, it console logs, and now our program is done. Similar thing with onClick. Remember how I said DOM is not really JavaScript. It's an API, third-party provided by the browser. So we'll add our document get element by ID. We'll add our event listener. That goes over to the browser API. So now it's going to sit there and listen for clicks. So we click our button, and it handles the click. And then it goes on the call stack. Since it's empty, it logs, things like that. So if anyone has ever been in a situation where the UI is not responsive and you try to click a button, why does it not click? It's because the call stack's not empty. Remember, callbacks don't get executed until the call stack is empty. So if you're doing a bunch of work in JavaScript, you're going to be blocking the event loop, and you're going to be essentially locking your whole UI. Or in the case of Node, it's even worse because you're going to be blocking every subsequent request to the server. So that's why I say in the talk description, I think Node has more footguns than PHP for new developers, because it's really easy to screw up in a big way and not even realize it, that you're slowing other requests down if you're doing synchronous stuff. So blocking example would be like this. We call setInterval to put something on the external API, and then we have this blocking CPU task that's doing something really heavy. This could be resizing an image, this could be doing some synchronous file reads or something like that, that are gonna stay in the call stack and just stay there for a while, and then our callback queue kind of piles up and nothing happens. And that's where you get something like this. If you do this in the browser for too long, you'll get a message that says this page is unresponsive. Would you like to kill it? Would you like to wait? I'm sure everyone's seen this. But this is essentially why. That website, when you get this message, something's blocking the event queue, and JavaScript and browsers detect this, and they say only for so long, and then they pop up this message so you can kill it and manually clear out the call stack. So do not use. So how do you avoid this? How do you avoid blocking? You don't use sync versions of functions, pretty much ever. There are some exceptions. If you're, for instance, when a Node service starts, I think it's okay to use synchronous functions, because Node, unlike PHP, is a long-running process by default. So the server startup, you might add some 200 milliseconds or whatever to the server startup if you're reading in config files. But once that process starts, it's going to run. So you wouldn't block anything after the fact. So there's some exceptions where you could synchronously read in config files when your service is starting or something, but when you're handling requests, don't do it, ever. because like I said, if you block that request and that's your node process, it will back up serving other requests. So resolve your callbacks asynchronously. If you have a callback that you're calling or passing around, you can actually use set timeout or set immediate to put it on the event loop manually, like I had mentioned before. It is good practice to just use set immediate with your callback instead of using callback and like calling it directly. And you can obviously defer CPU intensive tasks. So anything heavy, don't do in the main process. So there are ways to mitigate this. Ajax obviously in the browser is asynchronous by default, and you shouldn't ever put async. Like if you do jQuery Ajax, it has like an async false. Like never do that. I don't know why that's even a thing. The fetch API, you can't do synchronous. So they did that right. If you're familiar with the fetch API, it's promise-based API. CSS animations are GPU accelerated, hardware accelerated, so they're not going to block rendering. They're not like going to block the browser rendering. They can happen with request animation frames, stuff like that too. Web workers are web workers are a little bit unique. The way that they're implemented, each web worker process is actually a different JavaScript thread. So you can kind of cheat and have more threads in JavaScript, even though it's single-threaded, because it's its own like execution environment. So if you're using a service worker to do some offline task, that's why progressive web apps kind of require a service worker, so you can do stuff and not block anything, keep rendering really fast. In Node, you can do messaging like message queues, kind of like you would with PHP. Nginx, you can put a web server in front of Node to serve static assets. This is a common mistake a lot of people make with Node when they get started. They serve static assets with Node, and what that does is that means you're using the Node process to serve static assets, when you should actually be using Nginx or Apache because they can serve those static assets much faster. So you would put Nginx in front of Node with and then proxy requests, kind of like a PHP FCGI setup. You just proxy requests through, and you just do a regex pattern like anything with that ends in a certain extension or is in a certain folder. It can just be served as a static file, and then of course set immediate, like I went over already. So JavaScript, the language is single-threaded, but JavaScript, the runtime is not, because if you're, say, calling to the database and saying, get me these 200 records or whatever it is, the database driver is going to have its own thread pool that handles that. So even if you're piping a lot of requests through and sending a lot of traffic to the database is going to have its own thread pool and stuff like that. So the net effect is that, although a lot of people criticize Node for being single-threaded itself, the net effect is that it's not really, because you're not doing everything in JavaScript. And that might seem like cheating, but that's really how it works in every language. So PHP, you're doing the same thing. If you're doing PDO or MySQLi, they have thread pools built in. Those go out to the extensions, and you don't have to worry about it. So it's like when you establish a new connection at the, in the beginning of every PHP request, it's not actually always creating a connection. If it already has one open, if you're using persistent connections, it'll just grab it back out of the pool. Same kind of thing. So the key takeaway is a lot of people really riff on JavaScript a lot because they just don't understand how it works. They don't understand how it runs and why things happen the way they do. So none of this is magic. Just don't block the event loop and you'll be good. And JavaScript is actually faster than most other dynamic languages if you keep everything async. So that's the end of the demo. And now the Node specific stuff. Event loop. Okay, one note about the event loop. This is, all of that demo was taken from this talk. So if you want this talk in depth, I would either take a picture of this slide or note this guy's name. His name is Philip Roberts. He was one of the first to give this talk. I thought it was a good primer for to precede what I'm going to share with you next. And then this top link is actually like an interactive JavaScript execution model where you can paste in your own JavaScript you can paste in your own JavaScript code, and then you can step through the execution, seeing where things are going to the event loop or the stack or something. It really helps you understand how that code specifically is getting executed. So, highly recommended resource. Okay, so I've said the top two things. There is if you're using Node, there is a package called Node Blocked, which will help you know if you're blocking and where and for how long. So if you have written a Node service and now you might not be sure if you're blocking somewhere, or if you're just afraid you don't want to do it wrong or something like that, check out Node Blocked, and it will alert you. It will like console log where you're blocking. So if you're testing it, and it will give you tips on how to fix that. So really good package. Node.js. It runs forever, like I said. So unlike PHP, PHP is really nice actually from a server standpoint because it's shared nothing. It sets up and tears down for every request. So that's a really nice aspect about it. Things like Node and Ruby and Python are different execution model. They pretty much run forever. And so this does come with its own set of pitfalls. It means that if you're leaking memory and not doing things right, that process is going to continue running and continue to consume more and more memory until it crashes. So it can be faster because things are already loaded and they don't have to set up and tear down for every request. But on the other hand, you do have to be a little bit more careful about what you do. And of course, we went over the single-threaded asterisk thing. Single-threaded, yes, haha, not really, kind of thing. So this is a callback that you might be used to in standard JavaScript. This is just a simple jQuery AJAX. Probably everyone in this room has written something like this or copied and pasted something like this from the jQuery docs or Stack Overflow or whatever. The only difference between this and Node is that Node has an additional parameter. So Node-style callbacks are error first and then data. And if there's an error, then you'll check for the error. Otherwise, you'll be good. In the jQuery-style callback, if you only supply one, it'll assume success. Otherwise, you can supply like a dictionary that's like success is this function, error is this function. But Node, it's always going to be error, data. So 2 arguments, and you just check the first. Everything is async, so this is like a typical database call. So if I'm going to the users, the database users, I'm trying to find a specific name, I attach a callback when that's done instead of assigning that to a variable. And then whenever that's done, then I'll have, again, error users. So if there's an error, I'll send a JSON response saying, there's an error. If there's users, then I can pick out the addresses or something, whatever I want to send, and then send that. If you've never seen this syntax, this is ES6. The dictionary on the bottom, you notice it just has addresses once, not addresses colon and then addresses. This is like object destructuring in ES6. If you do it in Node, you'll get to use all these features and you don't have to transpile because it's just on the server. If you do this on the client side, then you'll have to transpile with Babel or something like that. So, and then the same with the that arrow function. It's an automatic return value, so it's an implicit return. So it's returning user.address for each user. And if you don't like that model, that model, the callback, if you've heard of callback hell, right? This model, if you can imagine, if you have to do some nested database requests, if you're doing, you have to fetch information for each user or do some additional processing for each user that's also async, you can get to kind of a pyramid-style looking thing that doesn't look very pleasant and is not very readable. Most of the time, that can be solved by just breaking up your functions into smaller functions and naming them properly. But if you really still don't like callbacks, you can use promises. I personally use promises. I really like promises. I think they make things a lot more readable. plus promises are the foundation of some future JavaScript stuff like async await and observables, RxJS, all that kind of stuff. So promises are basically, instead of callbacks, you would call your function, and then it returns an object that you can call .then or .catch off of. So a promise, when you have a promise object created, it's going to be in a pending state, and that promise can either be resolved or rejected. Resolved is going to be in .then. It's going to resolve with this value. So in this case, these are happening in sequence. We're doing something, and then we're doing thing 2, and then we're doing thing 3, and then we're doing thing 4. So each thing is waiting on the previous thing. So thing 2 is waiting for do something to be done. Thing 3 is waiting for 2 to be done. 4 is waiting for 3 to be done. They're one after the other. And then, we can do something with the result. The important thing about promises is the .then function always returns one and only one argument. So what we're doing here is we're assuming that do thing 2, thing 3, and thing 4 are accepting a single argument, and that the result of the .then is basically passing in the result to that argument when it's getting called. So it's kind of like the do thing 5 here. It's if do thing 5 was just a single argument that said result. We have to expand 5 because it expects 2 arguments, so this is why this isn't a callback and the other ones aren't. In JavaScript, you can functions are first class, so you can just pass them around willy-nilly and just shove them in a callback, and they can get resolved without you having to put a function around everything. And then we can do a .catch anywhere in this to handle any errors that come up. And a .catch will come up if a promise is rejected, or if you throw an error inside a promise, or in any of those previous .thens. And the thing to know about the .catch in promises is you can actually have multiple .catches, and if it's a error that you want to recover from, you can actually put a .then after the .catch, and it will execute. So let's say an error happened in do thing 3. It would skip do thing 4 and 5. It would go down to the catch and handle the error. So it skips all the thens, all the next thens until the catch, and then you can actually attach more thens after if you want. So you get a lot of control over the flow of your program using promises that is typically in a more readable way than callbacks. So they can be really nice. If you want to do parallel execution, that's really easy. And I misspelled execution, so I apologize. Just realized that. But you can do promise.all, and if thing 2, 3, and 4 are promises, this assumes those are all promises. So if those are promise objects, it will fire them off all simultaneously. And then the .then here will get called after all of those come back. So it's very easy to do parallel execution in JavaScript with promises. With callbacks, you can do it, but it's a little bit more difficult. A lot of people use third-party libraries or NPM packages like ASYNC, things like that. And there's a promise.race also that will call the then whenever the first one comes back. I've never used it in practice, though. I'm sure there's some things that it's useful for. I didn't put it here on the slide because I've just never used it. So, and again, we're calling .console.error on catch, and I've shortened it from the previous slide here because all we're doing is this is like saying console error E. If I put E in there, so I'm just shortening it to this. And since functions are first class in JavaScript, we can do that very easily. So callback style. So this is the difference between callback style and promises now. If you were to read a file in callbacks, you would have to do this, error JSON. These are going to be the same thing in both callbacks and promises. You JSON parse it, and you log it out. Otherwise, you catch an error and say invalid JSON file. If it passes in you an error on the file read, then the file doesn't exist. So 2 different error cases. We're wrapping a try-catch around JSON parse. Promise version is the same, is very similar. We do read file async, then we do JSON parse, then we do console log, so we're logging our results and parse. Remember, promises return. The then passes one argument, JSON parse takes one argument, so we can skip the whole formality of creating a closure. We can just pass in JSON.parse directly. Console log, same thing. And remember, if there's an error, it will skip those thens. So if there's an error in the file read, it will skip JSON parse and console log and go down to the catch. And this time in catch, we're supplying a first argument that's a type. We're supplying syntax error. So we can say there's invalid JSON in file. Otherwise, the default catch is I couldn't read the file. So that's the same thing as just doing this. If error, unable to read file, else try JSON parse catch error. So same thing in fewer lines of code, a little more compact. I like this version. It's more readable, but it's really a personal preference. What style you like. And then notice the read file, fs.read file, and read file async here. There's a feature called promisify. A lot of NPM libraries like Bluebird will have a promisify function. Basically, you can take, and Node 8, the newest version of Node, I think it's 8.1.2 now, or something like that, but it's Node 8 has this promisify library by default. So you can basically call util.promisify fs.readfile, and you can assign it to readfile async or whatever function name you want, and it will wrap a callback function in a promise. So then you can use it as a promise. So this idea is built in Node now. Databases in Node. So the process is running forever. It's not like PHP where you can just connect to your database on when you load your settings file or your config or whatever, and then forget about it and use it. You have to kind of be a little bit more conscious about this. In practice, you'll actually probably just use a third-party library, but it's not going to release that database connection, unless it's manually. So we had when I was doing consulting a few years ago, I had a client that that kind of encountered this problem, and that's when I hadn't gotten into JavaScript full time yet. It was like 4 or 5 years ago. They had this Node process, but I was just kind of there, just kind of getting into JavaScript full time, and they had this Node process that this WordPress developer had written for them, and it was working fine every day, but then at night when they would go home, they would have to restart the server every morning because it stopped working. And so they couldn't figure it out, and they had me troubleshoot it. And it turns out what was happening was a connection to the database was getting established when the Node process started, and MySQL has a timeout feature where if you're not communicating with the connection, MySQL very helpfully says, you must not need this connection anymore, and then closes it. And then from then on, when the Node service would try to send anything to the database, it says MySQL server has gone away, So they couldn't figure out why, and it's really because of this. It was a junior developer that had written it in the style that they would write PHP, and you just can't do that because it runs differently. So something to be conscious of. You might have to create a connection pool, but in reality, like I said, you really don't want to write this yourself. You're just going to use the library. So I highly recommend connects.js. It's a query builder. You can, in the bottom of the get settings function, you can just do connection.select whatever from, it's a very powerful query builder. Connects.js returns promises. So you can do a .then after this and chain your promise stuff. I think it actually does both callbacks and promises depending on if you supply a callback. Callback is the second argument, or do a .then. So it's pretty flexible. But this is going to create a connection pool for you, and you don't have to worry about it. So don't do it yourself. Just be conscious that you have to. It's something you have to do in Node. So another unforgiving kind of footgun in Node is that on error, the whole Node process crashes. It's very helpful. And so you need to be careful to catch and handle all errors. So the other caveat, the other footgun here is that try-catch might not work like you think if you're wrapping something that's executing asynchronously. Promises can help with this, but they also have some downsides. If you don't put a .catch on all of your promises, they can actually swallow the error, and you will never see it. So there are some things that can help with this if you're in Node. If you're in the browser and this happens, a lot of times you'll get a console error or something that says uncaught, unhandled promise exception, and then whatever. In Node, you have these events you can attach to the process. So you say process.on uncaught exception, and you can handle it there. I put exit1 with an error code. You'll always want to do this because if you get an exception in the Node process, you're kind of in an unknown state. If you're not handling the exception where it's happening, so you probably just want to exit the process. And once you do, then that process will get restarted. So there's also, if you're using promises, you'll have an unhandled rejection event as well. That will give you the promise object as the second argument here, and then you can say unhandled promise rejection and do something. And again, you're probably going to want to exit there. So make sure you're attaching .catches to your promises, or else something might not work, and you'll never know why, and you'll never see an error, and that's always a bad thing. Browsers and this unhandled rejection event was not always in Node. It was added to help with this problem, and browsers also are typically good now at detecting when there's an unhandled promise rejection, and they'll tell you. So it's helpful. So this is a try-catch around asynchronous code. Does anybody know what might happen here if we try to execute this? I'm actually going to execute this for you. Anybody want to hazard a guess? We're putting a try-catch. We're saying read file. We're doing the callback, and then we're going to catch that error that we threw, right? No, we're not. Okay. That's really small, I bet. Okay, so we're not actually going to catch that error. It's still going to throw. Why does it do that? Because it's a callback, right? So if you remember back to what I showed you, how Node's execution model works, the callback that we're giving isn't going to get executed until the call stack is clear. So we've put that code, that try-catch is executed right now, and all that code and the read file function is going to go in the call stack, and then that's going to get cleared off once that read file function is done. So when that callback gets called, that try-catch is gone. Like, it looks like it's going to be there. Reading the code, you would think it's going to be there, but that's gone. And then when that callback comes back and it throws, it just crashed your Node process. So you do have to be a little bit careful about using try-catch. I basically don't use try-catch in Node. I use promises and do a .catch at the end of the promise chain. They're not that useful unless they're everywhere, which is kind of sucky. So async await. If you like to use try-catch style like this, then async await will essentially be your answer. It is in Node 8, so you can use it as of the very latest version of Node. And that would look like this. Async await works on promises, so I'm assuming that this read file would return a promise. I actually should have named that read file async to make that more clear, but we're defining our function as async function, read some file, and then we're doing let file equals await fs read file. And this kind of looks synchronous, right? This looks like it would be blocking right here. If what I told you about always doing everything async, this looks like it would be synchronously reading that file into the variable and then, like normal code, executing it then after. There's kind of some black magic around this. It suspends the process and continues executing other code, and then resumes the process and continues executing your code when it's done. It's the same thing as doing this in a then, but it's a little more readable. So async await is really, really good. It's obviously async. but it looks like it's synchronous, so it's a lot more readable for a lot of people. Cool stuff. Okay, so network I/O. The other thing here is network I/O. There's no default timeouts for network requests. This is by design, so this isn't like a bug. So this is by design because if you open a WebSocket with Node or a server stream process or something, you want it to continue, to stay open the whole time. So sometimes you have to add a set timeout if you want one. If there'll be a timeout event, so you can do socket on timeout. You'll have to end the socket on timeout. So you have to handle timeouts if you're yourself, which could be, maybe a thing you don't have to do. And I'll kind of hurry through these last ones here in about 8 minutes. So if you're doing Express, you'll have to send. You get basically a request and a response object in each route. This is probably fairly common, most frameworks. But unlike most PHP frameworks, you can't return from this route. If you return from this function, it does nothing. You have to use that response object to send the response back. So you have to do res.send or res.end on the response if you're want to end that HTTP response. So anything else that you do in there, that HTTP request will go on, and they'll never get a response. It'll just open and it'll hang and it'll say timeout took too long in the browser. So you're explicitly sending a response. I say keep it dry. I see this in Node all the time, and this is because a lot of developers new to Node and new to JavaScript don't fully grasp that the first-class function nature of JavaScript. So they'll do this. They'll say these are two routes in the same file, and I'm doing the same thing in both of them, right? So there's kind of a lot of repetitive code here. I'm saying this function to send this JSON in this format, and then if there's an error, I'm sending this error in the same thing, and it's not very dry. And you can imagine this times 10 or 15 routes, what this might look like. So if you wanted to keep it dry, you can call a function and you can pass in the current request and response, because you need those to send the response back out. Remember, you can't just return from these. And then that function can actually return a function. So you calling that function, it's kind of like a closure that wraps around the current request and response. You're returning that function back to the then, and then you're sending your response with that. And so it can really clean up your code a lot. You end up with this, respond with results, whatever, and then you can format them uniformly just in a single function. So all your responses are the same format, and all your errors are the same. And then on catch, I'm using respond with error, and I'm passing in, again, the request and response, so I can send that response back out. OK. The last thing, this is kind of a little pop quiz. Is anybody, knowing what you know now, when is this callback going to get executed? Anybody want to hazard a guess here?
When does X empty?
Yes. Yes. OK, so most people would say this callback is going to be executed in 2 seconds. And that's actually wrong, because what you should read when you see this is this callback will execute in at least 2 seconds. And the difference is important because if the stack is not empty, this callback is not getting executed in 2 seconds. So it could be 3 seconds if you're blocking, the event loop. It could be 5 seconds. I don't know. But at least 2 seconds is what you should read. So good job. And that's it. So if you have any questions, I'll be happy to answer them. And please join the talk. Thanks, guys.